Hello, everyone. Welcome to Simulation Talk 280. Beautiful number, I would say. Hope everybody are doing great on this wonderful Saturday. Let me just connect my red light therapy thingy. What is that noise? Is that someone's phone, babe? How are you guys doing today? Guru, how are you, brother? Whoa, there we go. Awesome. Let's turn this on. Pretty. Wait. Boom. No, why isn't that working? Oh, there we go. There we go. It is working. Hello, power off. Welcome everybody on TikTok. Welcome everybody. You like the shirt by Eric? The Discovery. What a great shirt. Thank you, Eric. You're the best. Boom. Let's see what we got here. Thank you so much for sharing all the details, Guru. I appreciate you. Frank Valadez, beep. There's some chocolate in my teeth. Welcome everybody to the chat. Our Discord stage was a bit quiet, but I'll turn it on anyway. Just in case. It is up. Thank you for letting everybody know, Guru. I appreciate you. Glasses dinner. Smart glasses. Cool. Okay, welcome everybody to Simulation Talk 280. The channel revolves all topics simulation. Talk about simulation, talk about science. What's up? Talk about spirituality. Okay. If you guys want to help and follow us on Twitch, it'll be LaserX83 on Twitch. Come join us. It definitely helps the channel. Life has been treating me wonderfully. How is life treating you? Okay, let's see if we have some questions coming in. By the way, tomorrow we have the members live. That should be a blast. Hopefully you can show up. No big things are happening. Let's see if we can get into some questions today. Oh, what is that? What's up, Piggy Butt? Good to see you, brother. Anybody who wants to come on and chat, you're more than welcome to do so. Just raise your hand and I'll bring you up per usual. Peace be upon you as well, Guru. I appreciate you. I really appreciate the commitment. Downloads. What's up, Jason? Ooh, that sip of coffee was good. What is the dead shift, by the way? Where do you work? If you don't mind sharing, of course. Again, I'm going to say it again. If you guys want to chat, raise your hand. And if you are on Discord and you want to talk. Oh, on my way to Awesome. Jimmy McJimmyFace. I like the handle. It's very creative. What's up, Joshua? Good to see you, par off. Okay, so let's see if we can dive into some questions. A thing that was on my mind recently, maybe to kind of kick it off, is something that is on my mind often, but today was particularly pronounced for me. I don't know why. We have seem to have some kind of a breakdown of reason, and that always bothers me to some degree. I don't know why that is. For example, the rejection of, universal truth, things like this. Another thing that happened to me today that was kind of interesting. What's up, Nico? How you doing, brother? I'll bring you up because it's always fun to bring you up. Today, the talk that I invited you to, Nico, I saw that Charlie was there. I don't know if Charlie is with us here now, but it was super interesting. It was by the guy that goes by the name of Quantum Doug on IPI lectures. And he apparently was a computer scientist and researcher in quantum computation for the last 25 years. And he's been developing a very interesting physics model with something he calls existons. And what was super interesting is because it was basically a physics talk, that towards the end, he brought this girl who, because he, at the end, he admitted that he also gets like information, like he gets communication from like spiritual beings and things like this, which was very unexpected. And then he brought this girl to basically channel light language and to talk to us through this being that he also knows, to tell us that she supports everything we're doing. That was very interesting. I did not expect that.
Wow.
Yeah. So I'm obviously gonna reach out. I just started writing an email. I'm gonna send an email, and it was very unexpected and interesting. He himself said, this was very unexpected because I myself didn't expect this until last night when the girl that is channeling said that Blue something, that's the name of the being, wanted to talk to us. Listen, man, at this point, that was very interesting. I have to admit.
You see, I have to be more open-minded because that's hard for me to digest.
Bro, he's a serious scientist. He wrote some seminal papers. Like he's been in the circuit for a long time. But he basically incorporates consciousness, and he gave a very technical talk. So the talk itself is going to be on YouTube. I'm going to share it with you.
Nice.
The Q&A won't be, but yeah.
I just found out that Isaac Newton had written up to 1 million words on alchemy.
Mm-hmm. Oh, yeah.
His family won't release because they're afraid of tarnishing his legacy.
Yeah. Wait, Isaac Newton? Was that a known person?
Yeah. He ripped off Leibniz.
Oh, okay. I mean, back then, man, this was early chemistry, honestly. I really don't understand why people judge it by today's standards. Like, people didn't know. So that was early attempts of chemistry.
Yeah. They didn't have molecular structures back then. So it's super forgivable that he was into this stuff.
And also he was extremely religious, which, but everybody were.
Right. There's one thing I wanted to say, actually, because a few nights ago we talked about the Big Bang Theory, and I was kind of tired. My brain wasn't firing, but I wanted to make a point, which was one thing that's being shaken up right now by the recent DESI measurements.
Mm-hmm.
So for those that don't know, DESI measured that the acceleration constant is changing with time.
Mm-hmm.
So it's time dependent, but it's also dependent on space, on location,
mm-hmm.
which then suggests, well, maybe the universe is not as homogeneous as we thought. So the story, the origin story of all this goes that Einstein, he derived relativity and he added this constant called the cosmological constant which was intended to keep the universe static. And then in 1929, Hubble measured was measuring the sky and said, "Oh wait, the universe is actually expanding."
Mm-hmm.
And so then Einstein was kind of embarrassed by this term because he kind of just added it. He didn't derive it, right? He just kind of added it. He should have trusted the equations. But then in the late 1900s, we found out that not only is it expanding, it's accelerating. So we had to reintroduce that term back, right? And we called him a genius even when he's dead. And then what happened recently is we're now realizing, oh, well, that constant lambda, Einstein's constant, is a function of space and time. And so it seems like I was on Twitter kind of looking at what some people were saying, where like some people were like, this changes everything. And then like the standard cosmologists were like, no, it just fine tunes the lambda CMD model. It's not crazy. But actually what I think it's more powerful is that it sheds light on the early universe not being this homogeneous medium, but more of a heterogeneous medium. And what I think specifically it can give insight into, and this is where I have a problem with the Big Bang Theory, is they just extrapolate to t is equal to 0, and they say it was all homogeneous, it all exploded out of nothing. What I think this can shed light into, and I have no idea, but that the origin of the universe was actually chaotic. And what I think the reason why I like that is because when you run kind of like cellular automata, the beginning of these phenomena, the beginning of this emergence is always chaotic, right? The beginning of this looks very chaotic, and then you have things emerge, like these quantum fluctuations emerge and produce things like, matter, antimatter, dark energy, dark matter, etc. Right? So I really do like the idea of potentially the universe not arising from a Big Bang, but like a very chaotic computation or a chaotic process.
Okay, so the first thing to notice is that the Big Bang Theory is not postulating that it came from nothing. It postulates that the proto state is infinite density, infinite energy, infinite density. So it's quite different. So it's a singularity, right? But really, it's a shorthand of saying we have no idea what that is. So I think the Big Bang Theory is very agnostic when it comes to the actual seed itself. There are a few attempts to kind of talk about breaking of symmetry in the beginning of time and all these things, but the actual mainstream, as far as I know, Big Bang Theory is not stating anything about the moment before or the moment from which it actually arose, aside from infinite, like the fact that it's singularity. And then there's a lot of things that we can say from a technical standpoint about the instances after. But I think that ultimately, and actually, you would really appreciate the talk that he gave today, because he essentially, recapitulated a lot of this, work that has to do, like Landau's work, and also what Melvin is essentially saying, which is computation ultimately is physical. And he explained from a very technical standpoint why, and he talked a lot about Clifford algebra and touched a little bit on octonions. And he connected everything from a very technical standpoint. And one of these things that he said is that there is this state before fields, before anything, where these axions exist and they are conscious. And the it's almost like the fabric of reality itself is conscious, but he has quite a technical explanation of it. It's very interesting. And in that sense, I think that what you're saying now kind of matches that. Like, yeah, you would have a state that is beyond our comprehension from this space, but it would have, I don't know, I know you mean probably from a technical standpoint, you're saying chaotic from a technical standpoint, right?
Yeah, chaotic in the sense that
unpredictable.
Yeah, unpredictable. And then there's some emergence, right? Like a lot of these things that we called side quests, right? Like these emergent properties from a computation.
So
obviously this is way out of my domain. I'm not an expert.
Yeah, but it's still fun to discuss. You're familiar with strange attractors in chaos theory, right?
Yes.
So I think that these random walkabouts, or whatever they're called, these random detours that you keep mentioning, that Andres and Michael Levine were talking about, I think we can potentially derive some strange attractor around them, like from them. Like they must be arranged around some function, even if we don't fully see it. And I think that function would tell us a lot about what's going on behind the scenes.
Yeah, that's a really cool concept, actually. I really like that a lot.
Yeah, the question is how we do it. So I guess let's see how we. So usually strange attractors are derived by studying the larger scale operation of a chaotic system, and you watch if there's any regularity, not of each part of the chaotic system, but is there any higher emergent phenomena that you can talk about its repetitions? For example, the bifurcation. Even though we have this chaotic system, the bifurcation inevitably happens. So for example, you can say that and it inevitably jumps octaves, right? It goes from double to triple to quadruple, right? So, and this bifurcation, so I don't know if it's considered to be a strange attractor, but I think it should be then, right? Because that's a regularity in the chaos. Another famous strange attractor is Lorentz attractor, which states that nothing can ever repeat exactly the same way, ever. That's basically
a classic one.
That's a classic one. And then I'm not actually I don't exactly remember how they were arrived at, but they always involve seeing a regularity in a chaotic system that encompasses the entire fractal. So what would be, not what would be, because that's obviously the question, but how would we go about determining what can potentially be this repeating pattern that we can see in these? So for example, can we look at, do these side quests include a particular functionality that has to do with vector searching or something like this? Like, can we make some postulations about what it tries to do while it's not doing the task that it was quote unquote given? And how would you even go about that computationally?
I think that's the hard part of all this, is that it's hard to predict. See, you kind of have to just run it and see what emerges.
Can't you run and it's a real question. I don't know enough, or to be more accurate, don't remember enough about unsupervised learning. There's no some variation of unsupervised learning that can detect something we didn't anticipate to see, or you always have to have some assumption?
You can monitor. I saw this one paper where someone made a neural network observe a other neural network so that it could try to decipher meaning from it, right? Or kind of do this black box learning on it. So I think people are starting to layer this stuff. Obviously, it's extremely, you just like multiplied the computational cost of it. But I think in terms of, deriving some sort of logic from the side quests, I think that's a possible way of doing it.
Wait, actually, in order to help me, can you give me an example of unsupervised learning that we know about that we just...
Yeah, so unsupervised learning would be essentially like if there's this training set out there for identifying. The example is, the first example ever done was building an AI model that can determine if an image is a bird or not a bird.
Okay.
And the way you give it 1 million pictures of birds.
Oh, so you do give it. You do give it a picture of a bird. So you are conditioning it.
Yeah, you give it some sense of, this is what birds are.
Okay.
And then you give it so you have to kind of like precondition it. And then you give it a massive data set and say, okay, based on what you learn, here's a bunch of birds from all these kind of obscure angles, different lighting. And then what it's going to do is kind of run wild with it, right? And try to train itself in such a way that you are not kind of holding its hand through that training process.
So that's not the 80-20. So it's not, you don't give it 80% data and 20%.
Yeah,
that's supervised. Okay.
Yeah.
Okay, so unsupervised, you basically give it like a much larger data set than the one you trained it on, and you want to see what it does.
Yeah, like the whole internet, like all the pictures on the internet.
And how do you combine, in this case, if you want to combine unsupervised and supervised, how do you do that in this case, for example?
So you would actually try to combine two models that are kind of unsupervised. You would create an observer with one model, and you essentially say you have access to all these weights, you have access to the inputs and the outputs. What is going on in the middle, and all these layers, all these convoluted layers and activation functions? And what that model is trying to do in a very black box way too is like try to derive or find patterns and meanings and try to kind of keep track of that, kind of like a bookkeeper.
Wait, so is it kind of like a derivative of the first one? So it's like it tries to do unsupervised learning on the kinds of decisions that the first supervised learning deep network is doing?
Yeah, exactly. So like if you were to train a neural network to identify pictures of birds, for instance, you as a human could process the input, which is a picture of a bird, and the output, which is the classification, whether it's a bird or not a bird. But the problem is you don't have the computational bandwidth to keep track of all the features in between the layers of the neural network. So instead, what you do is you replace yourself as the observer with another neural network, which does have the computational bandwidth, but can kind of maybe focus on, tracking features or patterns and saying, this model has picked up that beaks are a number one determination feature for birds because beaks are very unique to birds, right? It could be something like that. So that kind of stuff is because the problem with black box learning, specifically in science, is like typically when we do science, we have a mental model and we derive with the chain of thought we deduce something. But when you're using deep learning models, it just tells you the final answer. And you're like, okay, well, how do I build confidence that this is the right answer? And so one way of building confidence is to be able to see the work, right? And that is where this kind of like layered unsupervised learning comes into play. But it's still kind of a new area of machine learning.
Interesting. Okay, yeah. Thank you for the reminder. Yeah, because it was a little vague for me at this point. Okay, good. So, okay, let's table this for a second. I want to read some comments by Chili Shot. This is because I have a thought that is still formulating in my head. Chili Shot is saying the only model which can explain universe evolution from initial uniform ocean of energy names thermonuclear scattering. Okay. What means that energy compresses in matter, creates a space. So yeah, there's a lot of theories. I mean, I would be a little bit more careful with statements like the only thing that can explain. That doesn't exist. Like there's no such thing as explaining a thing only in one way. That's first of all. Second of all, I'm going to keep reading your messages out loud, but as I'm sure you already know, it's not about putting it in words, but putting it in math. And the second you put it in math, then it starts competing with the real ideas in the physics community. What's up, Leah? I don't know what this means. Sorry. The next comment over. What I said to you, Power Off, is that if you keep putting it off for some reason and you can't explain the reason, it might be a sign that it's not time for you. So I would pay attention to that. Energy compresses in the matter, creates space. Okay, from initial state where it was uniform energy, no concentration plus no space. Okay. No separation, no scattering, which can only be realized by field, space creation. Yeah. So again, my last comment stands. Like the second we start putting this into math, that's when it starts being tested. And I agree, we can probably do without money, but currently we didn't find a good system to do so. Wait, what? Which push from each other. I don't know how people cannot understand it. My GPT Fu N, what is Fu N? His name is about a few times smarter and intelligent. Got it. Well, I think we have all our answers. How does AI distinguish between a bird, an owl, and a bat? Is that a joke or 500 mails I sent to the professors all over the world, plus people on chat forums? They as well have no idea what space expansion term means. I'm not sure what you mean by that. I mean, space expansion term is very easy to understand. The only question isn't if somebody can understand it. The only question is, can we measure it? What's up, Evil Icon? Good to see you. Oh, yeah. So that's the thing I wanted to also bring up to you. So, yeah, after he brought, it was like when he brought the girl to talk, like it was such a weird moment, but at the same time, it like felt like it belonged. But it really, it is interesting because he obviously is he knows what he's talking about. He's not some kind of a, also the way he talks, like he's very on it. And he was just like very matter of fact, like, yeah, like I'm experiencing these like spiritual things, and he brought this girl, and everybody just kind of moved on. I can't wait for you to see it. It was really interesting. I hope it was still doing the recording because
yeah, I'm down to listen to it. I posted on Discord a few days ago. There was like a PopSci article that was published on some scientists in China said that they've measured a quantum phenomenon in the brain where when charge flows through an axon, it polarizes the myelin sheath, which is this little fatty cable, layers insulating the cable. And that polarization moment is essentially like a quantum particle, right? Like it's essentially like this thing that can get coupled to other parts of the brain. And I mean, all of this is very hand wavy, and this is a very pop science article, but it's like it's interesting because I never even thought about those kinds of electrical effects in the brain, but I think of it more from like is there a particle in a box in the brain, right? Which we say the brain is too wet and hot for any quantum coherence. But would you say that he was a quantum consciousness guy?
No, quantum would be an emerging phenomena from his it would be already a derivation. So there's a deeper substrate beyond Planck, beyond all of it. So yeah, so basically he's saying that the reason that he thinks that he said a few interesting things. One of them, first of all, is that that math is real. Math is not physics. Math is physics. It's just that it's physics in a much deeper sense. And so he kind of approached it from the other side of where I'm approaching it. My argument around mathematics being real and not just mathematics, like in the sense of like it is as real as physics, because the second that you have a mathematical formula that makes sense to a mind, the mind is a physical object in the universe, and whatever information it contains is an object in the universe. So now that information about that mathematical truth is contained in the universe. It is an integral part of what is now possible to happen in the universe. So in other words, that information now becomes a potential of what can happen in this universe. So it is, by definition, maybe not actuated, but an actual thing that has implications about the future of the universe, or potential implications about the future of the universe. He came to it from a different standpoint because obviously his technical skills are just light years more advanced than mine, and he came to it from like a pretty deep analysis of computational science and mathematics and physics. So he kind of took it from the other side. He said when math arrives, it already is physical. It's just that we kind of interact with it because it comes from this like transition point between the where existons exist and how they execute into becoming three-dimensional space and all of that. And I'm gonna. The other interesting thing he said, which I think you will find interesting, about why from his standpoint, people are confused about their ChatGPT being conscious, is because according to his model, you can create interaction or influence from the spiritual realm to the physical realm, but you can't go the other way around. You can't have something physical influence something in the spiritual, in the where existence exist, because it just doesn't work like that. The signals always propagate in one direction, which is from the spiritual into the physical, and never the other way around. But he has a technical argument there, not just kind of words. Which brings me, before you respond, Nico, brings me to your question. I have to kind of bounce around so I don't ignore people. Chili Shot is saying, is not math an idea, which means first pure theory? Yeah, so a theory is not an idea. A theory is well-formulated argument that is in physics, at least, that is instantiated in mathematics, because you're asking me, math eventually can be put on, but I just wonder, what would you like to calculate? So I think there's a little bit of a misunderstanding of how this works. English is simply not good enough to describe what you're saying. So the words you're saying, they're not accurate enough, because the level of ambiguity of the English words you're using is too great to know if we're even talking about the same thing. Because everything you just said, you might think, somebody might be nodding at you, but they might be understanding something completely different than what you're saying. And there's no way to know, because you're talking about something so complex, advanced, and out there that we can't really put our hands on, that English is simply not good enough of a tool of describing it. The reason that it has to be in math, it's not about calculating it, it's about describing it in mathematics. Because in mathematics, there's a lot less ambiguity. There's still ambiguity, especially when you're talking about the more advanced things, because there's a lot of terms that are kind of, play a role that can be, well, it can still be understood in a different way, depending on what model you're looking through. However, it's prone to a lot less confusion. This is why, because everything you just said, if you only knew how many people a week email me with things like what you're saying, it's just they have their own version. And they're using a lot of big buzzwords that they've heard somewhere. They're going to put them all together. And I'm not saying necessarily you're doing it, but very often when you ask them one question about the details of what they're saying, they're like, well, it's this thing. They would say things like non-duality, or they would say things like quantum tunneling. I'm like, okay, but what does that mean? What are you describing? They don't know, because they don't know. They just heard it somewhere, and it makes sense to them. But what is not understood is that the word means something, but in order to truly point to it in physics, you have to describe it mathematically. If you want to put it into a theory, it simply doesn't work in any other way. So it's not about calculating. It's about describing. The language of mathematics is the only language currently that we know of that is accurate enough to even know if we're even talking about the same thing. You understand what I'm saying? Sorry, Nico, go ahead. I don't know if you had any comments on what I said before.
So, someone asked Wolfram a couple of days ago, why is the universe so mathematical?
Mm-hmm.
And he made a good point. He said, there's an infinite number of maths out there that are possible. It's just that, and a certain mathematical framework will govern a certain region, right? But right now, what we observe is that we have a mathematical framework that works for something, and then it breaks down. It can't describe something anymore, right? And what you end up doing is having to create a very specific form of math to describe that little pocket. And so what we're doing is we're building this piecewise model of everything, quantum, Newtonian, relativity. But the one framework that remains supreme is the computational one, right? Computational framework can do all of it. Now, it can do it slower in the sense that, me throwing a ball is very well described by Newton's laws of physics, F is equal to ma, you get this parabolic function, and you can predict instantly what's going to happen, where that ball is going to be at any time, any place. And so it beats computation in some capacity.
What does?
But a parabolic equation, like a function,
got it.
a mathematical description, can kind of instantly map an infinite number of trajectories for that ball.
Yep. Thank you for the gift.
But computation.
Continue.
Computation is supreme. Yeah. So, I think, so he flipped it back and said, well, my question now is, why is the world so computational, right?
Yeah. I heard him make that point, that he thinks that we arrived at a time where it becomes clear that the only way, everything I just said about mathematics, chill shot, Wolfram says, okay, now we start to understand that actually there's certain things that mathematics can't describe that only computation can. Because the rules of computation are the ones required to describe it accurately, because they're more computation-like than mathematics-like, which was a very interesting point that he made.
So the example is like a chaotic system. Like, you can try to describe it with math, but you end up having to fragment different regimes where the math works and stitch it together. Or you can just create a computational model and run it, and there is no discontinuity, right? It's all a part of the computation.
Exactly. Yep. You got if you want Chili Shot, you're more than welcome to come on Discord. Good opportunity for you to join our Discord if you're not on it. You can find the link on YouTube, and you can just come on and explain it, because I think from everything you're saying, and I mean it in the most neutral way. This is not a comment about you personally. Just what I'm observing in your words is that I think there's a misunderstanding here. I think. And we can clarify it a lot quicker if you want to come on, because you're saying things like there's no infinite connection because space separation, and by this infinite space cannot exist because space expands effectively. Well, no, because you can in physics have a bounded infinite space. I know it sounds weird, but topologically that's possible. In a few ways. There's a few ways to achieve this. One of them is that you might have a higher dimensional manifold that contains, on the surface of it, you have the universe we're on. So if it's a 4-dimensional space of some sort, then it can be infinite to us, because we'll always be on the surface. But the actual dimensions of the universe might be higher dimensional, so it can be infinite but bounded in that way. But of course it doesn't solve the problem, but it at least explains the observation we have. There's a few tricks. So like, it's not true to say that there's no ideas that can track the problem, but also I think the more important point, because I want to engage with what you're saying, nothing that you said so far seems to be resolving the issue, at least from what I understand from what you're saying. Quantum tunneling is the thing you don't understand, you see. Okay, got it. Well, as long as you know what I don't understand, we're on the same page. Hold on, let me grab something. All right, man. Well, then write a paper, submit it to a research facility, and see what they say. You should submit it for a peer review. That is the only way to make progress. That would be wonderful.
Dude, if God gave me the confidence for one day, dude, I would take over this world. I swear to you.
In what way?
I wish I had confidence, dude. Like, how do you say anything absolute, right? Like,
yeah. Yeah, it's amazing. I can explain things to that model: chemistry, refrigeration. Chemistry and refrigeration. Yeah, baby. I know. Thermonuclear scattering. I heard you. You know what? What's interesting is because I think I looked it up before. Yeah, particles, extreme environment. What? I don't quite understand your claim though. To say that you can explain things with it, what's up, Parker? Is not the same as actually explaining it. That is kind of funny though. You understand that all the physical models, all the theories, they're basically just one way of describing something. It's not the actual thing, and everybody knows this. Also, why everything is in caps, bro? I didn't say I understand quantum tunneling. I think I understand it to the same degree that most people understand them, if they're not a physicist. But also, I'm not really sure what you're even talking about anymore.
Quantum tunneling is like a very, very specific property of quantum particles. I hope he doesn't think he can walk through walls or something.
I'm not sure what he thinks. It's not very clear. Is there a test after this chili? That's really funny. Will there be a test after this? Pop quiz. You're right, Power Off. It's a sausage. That's the answer to everything. Elon Musk's quantum tunneling under LA. Nice. All right, man. All righty, dude. Feel free to submit your paper. And if it holds water, it holds water. That's the beautiful thing about science. When do we begin to group gnosis and ascend from this plane? No, again, I like this plane. I know everybody trying to ascend. I'll show you some heavy messes. That's really funny. That's really funny. Oh, today I think I promised Kelsey to do it a little shorter. Let me see. Parker, it's very funny. Hold on, let me see. Let me see if I have to adjourn or not. 1 second. All right, yeah. Gotta go and keep company. My beautiful pregnant wife. My nose is gnosis. Parker, please stick around. This is great. Okay, so today it's a little abrupt, but yeah, I have to adjourn a little bit earlier today. So we'll do that for today. Everybody should follow our wonderful guest, Nico, on TikTok. NIKO MACKAY, NIKO MACKAY. Nico, thank you so much for always being here, entertaining, and having a good chat. If you want to follow me across platforms, you'll be Danny Goller on TikTok and Instagram. You'll be Goller Danny on X, LaserX83 on Twitch, and Dango Thoughts on YouTube. DANGO Thoughts on YouTube. Come join the membership program because on Sundays, tomorrow, that means we also have members lives for members only, which we dive much deeper into all kinds of topics. You can join that. Also, we have a Zoom call coming up on Wednesday. If you join from the second tier and up on the membership program, email me that you joined second tier, and I will send you a link to our meeting. It'll be fun. There's not a lot of people, so it's a pretty private meeting. It's pretty fun. We get to actually talk one-on-one or 1-on-5 or 8, whatever. In any case, it's a lot of fun. So you can join that. You can also check our website, codeofreality.com. Codeofreality.com if you want to check out our merch. If you want to check out all the stuff with the lasers and the project protocol. You can follow our group on Discord. Please come join. We have an incredible community there. The link to which you can find on YouTube and on TikTok in the link tree. You can still contribute to the film. If you find the trailer, go find the trailer on Dango Thoughts on YouTube, DANGO Thoughts. The Discovery, in the description, you will find the GoFundMe page, and you can still contribute to the film. If you contribute over $1,000, you will get an invite to watch the movie for the first time ever with everybody who donated that amount and higher. There will be a very nice group of people that will see the movie for the first time ever before anybody else has ever seen it. I think it's pretty cool. If you can't, totally cool. You'll still see the movie. It'll be already close to the end of the year. Thank you so much for everybody who are always supporting. You can, what am I forgetting? Forgetting something. I know I'm forgetting something. Want to encourage, per usual, to donate for the person of need. We are still, I think today should be the last day. I think there's a few bucks left to donate to Casey. We're donating to an individual by the name of Casey who is living on very little throughout the month. Every dollar that you guys donate goes directly to Casey. This channel does not keep any of the money. It goes 100% to the person of need. And it's kind of cool because we have a lot of people coming through here every single day. And if different people on different days donate $1, we can actually feed and house people who live on very little. Casey lives on $150 a month. We almost raised all of it, which means that for this month, he has enough food and he doesn't have to sleep outside, which is kind of amazing. Then we can keep doing this because there's other people of need. I will identify particular people that I know for a fact that actually are a person of need. And my guarantee to the channel, of course, is that we will always donate to someone who actually needs it and not just people kind of saying they need it. And then slowly but surely, as the channel grows, we will also find a way to aggregate the funds and the attention in a way that can help a lot more individuals, also in a more structured way. So if you have the ability, thank you so much, Evil Icon. You're a blessing. Thank you so much for the donation. And make sure that you never donate something you can't. If your $5, $1 is something that you will miss, which means that you would have to not get something you really need because of it, do not donate. Only if it comes with flow, with ease, gratitude, and it has to be that way. Otherwise, the energy is not settled. So that being said, I will keep encouraging people every single day. Thank you so much, Evil Icon. You've been donating, I think, almost every single day. So thank you so much for this. I think that's it. So I want to thank everybody. I want to acknowledge our incredible moderators. Guru, thank you so much, brother. Jessica, I want to acknowledge Ebony and Chris, who haven't been with us in the last week, but we love them dearly. And thank you so much for all the community members, the old and the new, always being here, always contributing, always engaging in fun conversations, and making this community and channel what it is. I really appreciate you guys. Without you, this is obviously nothing. So thank you so much for always showing up and showing support and showing love and showing understanding and curiosity. It's my favorite thing. Thank you, guys. See you tomorrow. Peace and love. Ciao.